Morning everybody, can you hear me? Morning, welcome to IISER Pune. How are you doing today? Good, all of you have had breakfast? Good, because that's one very important meal of the day that you can't skip, right? Otherwise you're not going to be able to listen to what Sutirth is going to say with utmost attention. So how many of you are coming to IISER for the first time? Okay, that's a whole bunch of them, but I see some hands down. Have you been here before? You didn't raise your hand. You've been here before? You've been here before. Wonderful. What do you know about IISER?
For pure sciences, and I'm actually not very as well, so that's why I went straight here to.
Wonderful. So he says this institute is for pure sciences, and he's not far from the truth. The institute is called Indian Institute of Science, Education and Research, and the idea was to excite students about science education and research both at the same time at the undergraduate level. So it doesn't just deal with natural sciences, you also have math, you have humanities and social sciences and earth and climate sciences programs here. And typically a student can get into IISER after their 12th grade to pursue a whole bunch of exciting areas of sciences depending upon your interests. So that's about IISER Pune. In addition to that, we also have PhD programs, which is beyond the scope of your sort of requirement at this point. But we have several departments here, 6 of them: math, physics, chemistry, biology, data science, humanities and social science, earth and climate science. So that's 7, right? So across these departments, a whole bunch of me and my colleagues try and impart science education and make sure that we make it exciting for students to learn about science, because science is a no, it's not just a subject, it's a way of life. It should become a way of life, yeah? My name is Sudha Rajamani. I am an associate professor in the biology department, where my dear friend and colleague Sutirth Dey is also a professor at. Coincidentally, he's one of the first IISER Pune faculty to join the institute back in 2007. So Sutirth did his undergrad and postgrad from Delhi University, and he did his PhD from an institute called the Jawaharlal Nehru Center for Advanced Scientific Research, which is in Bengaluru. He worked with a very famous evolutionary biologist in India whose name is Amitabh Joshi, and over the years he's gone on to become a famous evolutionary biologist himself. In addition to doing teaching and research, Sutirth is extremely passionate about exciting students about science, which is fundamentally crucial because science is a way of life. Awesome. So today he's going to be talking to you about the power of evolutionary thinking, and it hasn't been more important for us to have this conversation in light of very important changes that are being made to the curriculum. And by the end of this talk, the hope is that you'll go back and talk to your other friends, not just in your school, but across your communities, as to why it is extremely important to be thinking in this manner. Yeah? So without further ado, I invite Sutirth Dey to give his talk.
Thanks, Sudha, for that wonderful introduction. So, as Sudha pointed out, of late, evolutionary biology has become very, very topical, primarily because of certain announcements that have been made regarding removal of evolution from class 10th syllabus. So, what I am going to talk about today is about not only about evolution, and there will have to be some amount but not entirely, but mostly I will be talking about a particular way of thinking which I call evolutionary thinking, and hopefully try to show you how this kind of thinking is very, very crucial and goes far, far beyond the immediate topic of biology into things like sports, into things like medicine, into things like, I'll show you what all things I have in mind. One quick point over here that we are teachers, faculty, so we have a tendency to keep on talking okay, as all students know, right? So if at any point you guys have any questions, just put your hand up and ask me. Okay. Don't think that okay, this is too simple, this is too stupid, what will other people think, what will people from other schools think, etc., etc. Don't think about those things. All right. It's about your understanding, and if it is not making sense to you, there is a good possibility that it's not making sense to many other people. All right. So just stick your hand up and we will have a quick discussion, and whatever happens I will try to wind up within about 45 minutes to about an hour, okay, not more than that. So how many of you have ever been to a zoo? Okay, that's a hell lot. Okay, and how many of you have watched, let's say, Discovery or Nat Geo or BBC Animal Planet? Ah, excellent, great, many of you, right? Therefore, if I show you this slide and I say that there exists an enormous amount of diversity in terms of life forms, all of you will agree, right? Even if you don't go to a zoo, if you just take a walk on this hill nearby or any of the nice treks in and around Pune, you will be able to see hundreds and thousands of animals, and if you watch Discovery, you will probably be able to see a few more thousands. Now this is an observation, the fact that there are huge number of organisms, many kinds of organisms. This is an observation that people have been making since time immemorial. Okay? And another very interesting thing about the living world around us is that all these organisms, they seem to be, this is the first point, there is a tremendous diversity. All these organisms, they seem to be extremely well suited, extremely well adapted to whatever environment they live in. Okay? So let's say think about a bird. A bird has very light bones, it has wings, it has a very high rate of metabolism, it has so many other features, all of which enables it to fly, makes it particularly well suited for flight. Similarly, take a earthworm. An earthworm, it does what? It burrows inside. So when it burrows inside, what kind of traits does it have? It has a body which is very slim, it has the ability to dig, it has it's a fantastic ability to go inside the earth, etc., etc. So these two properties, lots of diversity and very well suitedness for their environment, this is something that is a well known feature of almost every organism on this planet. Now the question is why that is so, and this is a question that has been bothering human beings since time immemorial, and different cultures have come up with different kinds of answers. The earliest answers were mostly religious, God created it this way. Then at some point people asked, okay, can we go beyond religion, and there were lots and lots of theories until we came to this person, right? And most of you would have heard this name, right? Charles Darwin. So 1809 to 1882, around 1850, he gave a very nice theory of evolution through natural selection. Now how many of you have heard about this theory? Okay. How many of you know what it is? Okay, great. So we'll quickly talk about what Darwin was trying to say. So what Darwin was saying was very simple. Suppose you take a population. Okay. What is a population? A group of individuals of the same species. So for example, all of you are human beings, so you are a human population. Now if you look at any population, you will see that the organisms, they differ from each other slightly. Okay. So for example, just look around yourselves. Okay. All of you are roughly the same age, all of you are human beings, yet all of you have slightly different properties. Okay. Somebody has a slightly fairer skin, somebody has a slightly darker skin, somebody is slightly taller, somebody is slightly shorter, etc., etc. So this is what is known as variation, and the example that I have picked over here, I am talking about some species of insects, and let's assume for a moment that these species of insects come in two colors. Can you see the two colors? One is orange, so one is green. So this is a property that is called as variation. Okay. Variation exists within a species, within a population. Now because different organisms differ slightly in terms of their properties, many a times there is an effect on their survivorship, how long they live, and their reproduction, how many babies they produce. Okay? And many a times this is related to their properties. So, for example, suppose we are talking about a deer. Now, we know that some deers can run faster, some deers can run slower, some deers can't run at all. So, obviously, the deers that are able to run faster, they will be able to escape the predators better, right? The lions, the tigers, the cheetahs, whatever. And because they are able to do that, they will live more offspring, they will live more children, they will be able to survive longer, correct? So, in this example, what is happening is, let us say we have some predators, some birds, and let us say these birds, they prefer the green insects. Okay. So, they will keep on eating the green insects. So, this is the point where the variation in color is having an effect on how long they are living and how much they are reproducing. So, because of the fact that the predators are eating the green insects more, what will happen? In general, the orange insects, they will be able to produce more babies, correct? Now, there is a third component needed, and the third component is what is technically known as inheritance. Now, all of you know that in general, we have a resemblance towards our parents, right? Most of you, some relative or the other at some point or the other would have told you, you look like your mom, or you look like your dad, or you look like your uncle, right? Or auntie or whatever. Now, this is an observation that we humans have for a very long time, that not only in humans, but in all organisms, the kids, they resemble the properties of the parents. Okay? Now, in this particular case, the orange ones, they are producing orange insects, the green ones are producing green insects. Okay? That is what is meant by inheritance. Now, if the orange ones in general are able to produce more babies, then across time, over generations, what will happen? The number of orange insects in the population will go up, and the number of green insects will go down. And if you keep on repeating it for many generations, what will happen? All the green insects will be gone, and the entire population will become orange or brown, whatever. Okay? So, you start with a population which has variation, and because there is something which is acting on that variation, the population's property changes. A population which was earlier of two colors now becomes only one color. And this is what Darwin called evolution by natural selection.
So, what caused this variation at the first place?
What caused this variation in the first place? Brilliant question. So, in the context of insects, this difference will typically be caused due to some genes. So, different forms of that genes, some will lead to the orange color, some will lead to the green color. And therefore, when you are reproducing, you know that you have either those orange insects have the orange wala copy. So, they will be able to pass that copy, the green ones pass their copy. So, that is how the thing happens. Is everything okay? Okay? Clear up to this point? This is a very simple concept, but this is a deceptively powerful concept, as I am going to show you over the rest of the talk. So, these three components are necessity, and if these three components are there, evolution by natural selection will happen. Okay? It is almost a mathematical certainty that it will happen. Now, here is a very recent example of this. Okay? I do not expect you to look at this, but can you read whatever is written over here? Alpha, lambda, gamma, omicron, delta, delta. Do you know what this is? COVID-19, exactly, right? So, what happened was, we started with a particular strain, and then with that strain over time, so this is the way the evolution happened in those strains. Okay? So, this is where the whole thing starts, and then one branch went towards the delta, and in delta you had multiple strains. Similarly, one branch went towards lambda, another went towards alpha, etc., etc. One went towards omicron, correct? Now, you know that in India, we had multiple waves of COVID, right? Did any of you get COVID? How many of you got COVID? Huh. Oh, actually, good, good. Not too many, and that's very nice. Okay. No, because you guys were not vaccinated, right? So if you guys got COVID, it would have been a bigger problem. But nice to know that most of you didn't, or probably did but didn't get tested. Whatever. Now, if you look at the time course of these various strains in India, it will look something like this. Okay. So what happened was, you remember it started in 2020, right? March 2020 is when the lockdown happened. So initially, please switch it on. So initially, all the some other strains were there, and after some time, around 2021, this was the Delta strain. This was the first wave. This was the one where most of the deaths happened. Okay. So initially, you have other strains, and then mutations keep on happening, and then once you have the Delta strain arriving, the Delta strain is able to spread more, and therefore it ends up replacing all the other strains. Okay? This is exactly like what I showed you about the green beetle and the orange beetle. Why? Because initially you have multiple strains, but some strain, this one over here, is dominant, and then comes a strain which has faster reproduction, and therefore very soon it is able to replace the previous strain. So this is Delta, and after that what happens? What came after Delta? Big wave? Omicron, correct? So this is Omicron. And remember, in Omicron you actually have several sub-varieties. So these are the various sub-varieties. But each time you see exactly the same thing. It starts off with something, and then once the other one arises, very soon it ends up replacing the previous one. Okay. Now, this shows you that whatever I told you about how natural selection works, this is something that is happening all the time around us. This is like one big mega example. This is also happening in other contexts. So for example, whenever you get sick, your doctor gives you some antibiotics, right? And with that, the doctor always tells you what? Please eat all the antibiotics that I have given you. If I have given you a 3-day course, finish the 3-day course. If I have given you a 5-day course, finish the 5-day course, right? You have heard this from your doctors? But have you ever asked the doctor why? Why should I finish it for 3 days, or why should I finish it for 5 days? No, na? Most of us don't ask the doctors, but you should always ask the doctors. Okay. The reason is that when you are taking an antibiotics, essentially inside your body there is a process of natural selection happening, the way I showed you with the beetles. So what is happening is, the bacteria, it carries some changes which are known as mutations. So whenever those changes happen, these new bacteria, they are able to do better than the old bacteria, and therefore very soon, just like how these strains, one is replacing the other, very soon inside your body you get a bacteria which is not killable by that drug, by the antibiotic. Once that happens, what will happen? Even if you take the antibiotic, your disease will remain. Okay. And worse, what will happen? That bacteria will pass on to other people. So when they get the disease, even when their doctors give them the antibiotic, it will not work. To prevent this from happening, this is known as antimicrobial resistance, and this is something that is a huge problem in medicine right now. And that is why the doctors are pleading with the patients that please take your antibiotics properly. Now, there are hundreds of such examples that I can give you of how natural selection is very important and is all around us and is basically affecting every single facet of our life. But that's not what this talk is about. That is stuff that you can get from Nat Geo and Discovery very easily. What I'm going to talk to you about is this thing called evolutionary thinking. Okay. And now let us go towards what is evolutionary thinking. Now, suppose we have the coronavirus and we ask the question, why is the coronavirus the way that it is? Okay. Now, if you ask this question, there are several ways in which you can answer this question. One way is basically appealing to God. Okay. God made it this way and therefore it is, It is here because we human beings have been doing all kinds of nasty things to nature, and therefore this is God's way of punishing us. Okay. Now, per se, there is nothing that can be said against this way of answering this question, because there is no logical way to check this out. We don't logically know whether God is really doing this or not. We think God is doing this, and that's about it. The bigger problem is, if we know God is doing it, we don't have any clue about what else God wants to do. Okay. So, if there is another pandemic tomorrow, we will attribute it to God. If there is no pandemic tomorrow, we will attribute that also to God. One is to God's mercy, the one is to his anger. Okay. But either way, sitting here, we can't predict what will happen tomorrow. Correct? Therefore, this way of answering the question, this is not something that is amenable to scientific discourse. What is amenable to scientific discourse are the two other ways of looking, one of which is known as the proximate way or the mechanistic way. What does it mean? So, for example, this person asked me that why is this insect green and why is that insect orange? What makes it green? When he asked that question, what he meant was, what is the mechanism by which this one is green, this one is orange? What is the mechanism by which somebody is short, somebody is tall? What is the mechanism by which somebody's eye color is blue and somebody's eye color is black? Okay. So, in order to answer these questions, we will talk about genes, we will talk about the various chemicals those genes are making inside your body, etc., etc. However, so this way, this is obviously a very scientific way, and there is enormous amount of understanding that we have gathered about the coronavirus in terms of its mechanisms. Okay, all of you would have heard about spike protein and all those nice terms. However, once I tell you about selection, there is another way of looking at this whole thing, and that way is the so-called evolutionary way of looking at this thing, which is to say that this coronavirus, it is able to replicate and it is able to become so prominent, and one strain of it is able to replace the other strain of it. Why is it able to do so? And the answer to that question is because it has these properties which are enabling it to become a faster reproducer, which is enabling it to make more copies of it. Okay. Once you think about it that way, then essentially whenever you have a problem, whenever you see a phenomena, what you ask is that evolutionarily speaking, who is getting benefited? How is the organism getting benefited by this? And once you ask this question, how is the organism getting benefited by this, or in some cases, how is the organism getting harmed by this, then you reach a completely different set of answers. Okay? And that is what I mean by evolutionary thinking. And as you will see, strangely, this way of thinking can actually take you far beyond evolution. So, are all of you with me till this point? Any questions? Any comments? Okay, this is just the intro. Now the talk starts. Okay. So, the first example that I will take is related to breeding chickens. Okay. And all of you know that chickens are bred for two major reasons. One, for their eggs, the other is for the meat. So, in this particular context, I am only going to talk about breeding chickens for their eggs. Okay. So, you know that poultry farming is a huge business, not only in India but all over the world, and has been so for a very long time. So, in commercial poultry farming, obviously people want chicken which lay more and more eggs, and therefore people have been trying to select for such chickens for a very long time. So, what do they normally do? What they normally do is they take a large number of chickens, they check which one of them is laying how many eggs, and then they take the one that lays the maximum number of eggs and allows it to breed for the next generation. Okay. So, only the ones which are breeding the maximum, they are the ones which are allowed to pass their genes to the next generation. However, that way takes you so far and no further, and I will tell you what I mean by that. So, there was this very famous person called William Muir. He worked in a university in the US called Purdue University. So, he said that look, I understand that you guys are selecting for chicken this way, but I think we can do it in a slightly different way. So, what was the difference? So, what he said was, you take groups of chickens, many groups of chickens, and then you count all the eggs laid by a group together, okay? And then you select those groups of chicken which together as a group are laying the maximum number of eggs. Okay? So, the traditional way is you track each individual chicken how many eggs they are laying, and you select the ones, the individuals which are laying the maximum number of eggs to create the next generation. Here what they are saying is, do not track the individual, track the group, and when you track the group, select that group which is leading to maximum number of eggs. Okay. It is a very different way of doing it, and obviously the first question that was asked was, no, nice of you to say this, but does it even work? And when he did the selection for just 6 generations, very small amount, what he got was fabulous. So, these are the selected chicken, and they are called KGB, and I will tell you in 1 minute why they are called KGB. Do you know what is KGB? Otherwise, why KGB was famous? Russia? Yes. The Russian spy agency, right? Committed Gosudharavastanu. Anyway, so these are the selected chicken, these are the normal chicken. And what he found was that within 6 generations, the death rate in the normals is 30.6, but the death rate here is 8.8. It has gone down about 3 to 4 times. The lifespan here, how long they are living, is 160 days. How long they are living over here is 348 days. It has doubled. Okay? And the number of eggs that they are laying, this is over their entire lifespan. Each hen here is laying about 91 eggs. Here they are laying 237 eggs. That is more than 2.5 times. Okay? So, obviously, when you are selecting them as a group, they are living longer, laying more eggs, dying slower. So, obviously, these are much better chickens, so it works. But the main thing is not this. The main thing is, how do these birds, they compare to the birds which have been selected individually for increasing egg yield, right? And those birds are known as the super chickens. So, when he compared, William Muir compared the performance of the chickens, what he found was very simple. When you keep the birds separately, the super chickens, the ones that were selected individually, they lay more eggs. But when you keep them together in cages as they are kept in normal poultries, then it is the KGB guys which laid more eggs, but the main difference was somewhere else. So, these are the KGB birds, these are the super chickens, okay, kept in bunches of 12. Can you see the difference? These birds, you can see the KGB birds, they are fat, they are well fed, right? And more importantly, you can't see all of them, but there are all 12 of them are there in the cage. In this one, do you see how bad they are looking? They don't have feathers. You know why that is so? Because these birds, when you select them individually, they end up becoming very, very aggressive towards each other. So, when you keep them with each other, they fight, they peck each other with their beaks, because of which this is the condition that they become. And you can see only 3 birds here. You know what happened to the other 9? They died. These 3 essentially ended up pecking the others to death. And because of all that, the death rate here is 89%, the death rate here is only 20%, right? And more importantly, if you look at how they are doing to stress, these birds are actually doing much better to stress, they are much better able to face stress than these ones. So, now I can tell you why these are called KGB. KGB stands for kinder, gentler birds, okay? That is the name that these guys gave it, kinder, gentler birds. Now, why is this happening? So, remember, in this case, what did they do? They selected those birds that laid the maximum number of eggs. Now, when you are selecting for birds that are laying maximum number of eggs, there are two ways in which egg number can go up. One is you lay a lot of eggs yourself. What is the other way? No, that is for these ones. I am only talking about these guys. Ha, bola?
To reduce competition.
No, not reduce competition. When I am talking about these birds, okay. When these birds, they want to become the ones that are laying maximum number of eggs, either they can lay lots of eggs themselves, or they can prevent the others from laying lots of eggs, right? So if I don't let the others lay lots of eggs, automatically my number of eggs, even if it is small, will be greater than others. So this is like, you know, burning the textbooks of everybody else in your class. Nobody else will be able to study. So even if you study just 10%, you are still the class topper, because nobody else has been able to study anything, right? So because of that, these birds, they have essentially ended up becoming hyper competitive. However, these birds, they are laying as a group. Therefore, for them, it is much better to be team players, correct? And therefore, these ones actually evolved to become the kinder, gentler birds. Now, if this is the situation, this is kind of, does this ring a bell to any of you? Can you see some parallels? Okay, let me show you some parallels. Can you guys identify this? I mean, I have written it below, but can you guys, without looking at the text below, can you guys identify what these are? How many are football fans? Okay. So Real Madrid and FC Barcelona, Football Club Barcelona, what are these two? They are very famous football clubs. Where? Spain, La Liga, correct? The Spanish league is called La Liga, and these two are like the top two in that. Now, both of them are very rich, both of them spend lot of money, but there is a slight difference in terms of their money. So Real Madrid between 2000 to 2016 ended up spending 1.22 billion US dollars, okay. So 1 billion is 10 to the power 9, okay. So anyway, doesn't matter. So these guys spent 1.22 billion and won 18 major trophies. During the same time, this football club Barcelona, they ended up spending 0.847 billion, which is much less, but they ended up winning 10 extra trophies, okay, 10 major trophies. So why exactly was this difference between Barcelona and Madrid? Okay, so football fans, do you have any idea?
Barcelona usually got players from their youth academy.
Yes.
Cost much less, but they were good quality players, so they were able to win more trophies. While as Real Madrid, they spend money on the players who are playing for other teams, they will also spend a lot of money, but got this.
That is half the answer. Yeah, you are right. Bola.
Real Madrid white players, when they had an extremely good World Cup, but they did not know that they were not in their primes, and hence the players flopped at Real Madrid, and Real Madrid had to end up selling them.
That is part of it, but the flopping is not entirely because they were not in their primes, because Real Madrid never got anybody who is not in their prime, okay. They only got guys who were in their top primes. What he said is more to the point, but for rest of you who don't know Barcelona and Madrid, let me tell you. So in the European football system, you have this thing about buying and selling players, okay, and there is a huge amount of money involved. It's much like IPL, right? All of you know about IPL, right? There is auction and you buy and sell players, and players transfer from one club to another and so on. So in 2000, the president of Real Madrid, he came up with a policy known as the Galactico policy. And you guys have heard of Galactico policy? Excellent. So Galactico policy was very simple. Galactico policy was Real Madrid will figure out who the topmost people are in football in the world, and then no matter the cost, Real Madrid will go and grab them and bring them to their team, period, okay. So between 2000 to 2016, Real Madrid actually broke their own record of paying the maximum amount of money to get the players, 6 times, 6 or 5 times, okay. So Figo, Zidane, Kaká, Cristiano Ronaldo, Gareth Bale, these were all people who were bought with increasingly greater and greater sums of money. But at the same time, Real Madrid was very ruthless. If the players came and they did not do well, they would sell them off. So, and also Real Madrid was very, very ruthless with their coaches. If the coaches, if the team performance was not good, Real Madrid would simply kick them out. Okay. As a result, the players in Real Madrid were under massive amount of pressure at all the time. And therefore, and because Real Madrid had this policy of having only the best and selling off the worst, therefore, the players, more than playing for Real Madrid, many of them were playing for themselves. Because they were always worried that if I don't play, I will be sold off to some lower grade team, which they didn't want. At the same time, Barcelona, as he pointed out, had a very different thing about this. Barcelona said, okay, we have our youth academy, and most of our players, we are going to train them right from the beginning. And Barcelona has this motto, more than the individual. Okay. So it instilled in their players the thought process that you are good only if the team is winning. If the team is not winning, you might be performing brilliant, but that is not worth anything. Okay. By the way, this is also there in the Brazilian football team. They instill this thing in the Brazilian team. So because of this difference, the amount of money that Madrid ended up spending was much greater, but they had to settle for slightly lower level of results. Of course, after 2016, things went a little haywire, but that's in a different direction altogether. Incidentally, is there an Indian parallel? We talked about IPL, right? How many of you watch IPL? Good. That's a much bigger number, obviously. Which are the two most successful teams in IPL? Ek minute, ask that. Chennai and Mumbai. Chennai and Mumbai, right? Both of them have won how many? Five titles each. Not only have they won five titles, if you look at the overall number of matches that they have won, Chennai and Mumbai are right at the top. Okay. Now, in terms of player retention in the team, which are the two top teams in IPL? CSK and RCB retains only its marquee players. RCB doesn't retain anybody else. It only retains Virat Kohli and AB de Villiers. But overall, if you look at in terms of retention, Chennai obviously is way ahead of anybody else. But Mumbai in general also retains more than others. Okay. Kolkata and Punjab, they are probably the worst in terms of player retention. Okay. Also, good. So one thing is, if you are retaining your people, irrespective of the results, that works, as Mumbai and Chennai have shown. The second thing is, in term, being kinder and gentler in some sense. So you guys know about the Fair Play Award? Yes. Which team has won the maximum Fair Play Award? CSK. How many? 6. Not 9, 6. Okay. So again, that tells you that when you are talking about something in a team context, then the kind of traits that you want to select for, the kind of properties that you want to incentivize, okay, things that you want to give rewards for, that are very different from the kind of traits that you are selecting for individuals. So for example, suppose this were tennis, okay, and individual singles tennis, not doubles tennis. Will this work? No, because in tennis, singles tennis, each individual is playing for himself or herself, correct? So there you actually need to give incentive to the individual's property. But when it comes to team games, you have to give incentive to the ones which are playing for the team, correct? Incidentally, this is something that has come home in most corporate. So for example, corporates like Microsoft and Amazon, okay, in all corporates, if you are a star performer, you get big bonuses, you get big promotions. If you are not a star performer, then things don't go well for you, right? And people have actually cited this study from on the chickens and they have ended up showing that all those companies, and Amazon is like the worst offender over here, all those companies which have a tradition of lot of competition among their own team, they invariably do worse than those companies which have a tendency of boosting their own group, okay, the whole group. So, the main message over here is that when you want to improve individual performance, prioritize your individuals. But when you want to improve the performance of the group, prioritize the group. Okay? Now, you can, I'm sure you can think about many such examples around you where the, which one you prioritize completely changes the amount of success that you are getting. Okay? Now, I'll move to the second example. But before that, do you guys have any questions on this? Comments? No? Okay. So, example 2. Can you recognize this? It's a blue circle, obviously, but what does this stand for? The quizzers, how many of you are quizzers? No quizzers here? Okay. This is the universal symbol for diabetes. Okay? All of you know diabetes, right? What happens in diabetes? Typically, the blood sugar levels go up. Typically, you tend to get thirsty a lot more. Typically, you tend to urinate a lot more. And if not treated properly, all kinds of bad things happen to you, right? Now, okay, from this point onwards, I am going to talk about stuff that is still not 100% resolved in science. Okay? So, normally whenever people talk to students, they talk about stuffs that have been extremely well established, which are things that were done 30-40 years back. All right. However, now I am talking to you about things which is still work in progress. These are hypotheses that have been given, but people are still trying to figure out whether it is the correct hypothesis or not. So, they are trying to collect information and so on. So, when it comes to diabetes, diabetes has become a massive problem all over the world. So, according to 2019 data, there are 537 million diabetics in the world. Okay? So, 1 million is 10 lakhs. So, 537 million means 5370 lakhs, 5370 lakhs, which means 53.7 crores, and this is 4-year-old data. I am sorry, I couldn't get hold of the 2023 data. And this shows how this is spread over the entire world, and the deeper the color, the more is the prevalence of diabetes. And if you look at it, of course, the deepest is here, but if you look at it, India is also pretty bad in terms of diabetes. Okay. Now, why does diabetes happen? So, as somebody pointed out, it is because sugar levels go up. Why do sugar levels go up? Because there are some hormones in your body. Which one? Insulin. Insulin, exactly. The production of insulin goes down. That's the common way of talking about it, and it is correct. That is the proximate reasoning. However, because this has been spreading so widely, people have been asking questions, scientists have been asking the question, what is the evolutionary reason for it? Can there be an evolutionary reason for it? And there have, yeah, bolo. Inheritance is there, but inheritance is there for every trait in your body, na? Just because there is inheritance doesn't mean that the disease will be there. The disease will happen if and only if there is something which is getting benefited or not benefited. So, that is what people are trying to figure out using the logic of selection. So, the main logic that people have come up with is that perhaps when we evolved, we were evolving in a manner when there was very less food. Okay? And therefore, our body is extremely well suited for taking whatever nutrition whenever it gets and storing it, and utilizing it to the maximum, so that maximum amount of nutrients can be gotten into the body. However, now we live in a world which is not like that. Now, because of agriculture, because of poultry farming and all these things, there is a lot of resource all around us, And because of that, we nowadays have an excess amount of resource that we are getting. And think about it, that is probably true. If you think about what, let's say, your grandparents used to eat, how many calories versus how many calories you eat, there is a huge difference. Most of you eat more calories than your grandparents used to eat. Okay. So, one evolutionary hypothesis says that it is because of this mismatch, the fact that we are eating more calorie-rich diet, that diabetes is happening. However, there was there very much is a very famous evolutionary biologist from Pune called Professor Milind Vatve. Okay. Have you heard this name, Milind Vatve? Some of you would have heard, yes. So, Milind Vatve, he came up with a slightly different theory for this. He said that when we were living as hunter-gatherers, we lived a very active life. And not only active, this was a life in which there was a lot of risk being taken. When you are going to hunt an animal, you are always liable to get injured, right? You have to run a lot, because of which you are going to get scratches in your body. So, there are lots and lots of biochemicals in our body which have evolved in response to that kind of a life. Now, when we have come to this modern life of ours, one of the things that has happened is nowadays we hardly have any risks of that kind, physical risks of that kind. Okay. It is not that our life is tension free, no, we have lots of tension, but all those tensions, none of them have to do with physical damage. All of them are like, okay, I will be able to pass this exam or not, and whether I will get that admission or not, and so on, but not physical damage. And his main theory is that this entire epidemic of diabetes that we are getting is because our body has evolved to be good under that kind of a risky scenario, and nowadays in our life we do not get that kind of a risk. So, obviously, he has looked at the scientific literature in great detail. He talks about the molecules which are responsible for this, and he wrote this very interesting book on this particular theory. However, the outcome of this was very simple. So, if your body does well under aggressive threats, but nowadays you do not have aggressive threats, so what do? You get hold of aggressive threats. So, in order to do that, what he has done is, you guys know about Dinanath Mangeshkar Hospital, right? Right here, Erandavane. So, in collaboration with Dinanath Mangeshkar Hospital, he has come up with this clinic inside Dinanath called Behavioral Intervention for Lifestyle Disorders, or BILD Build Clinic. So, in this you still do exercises, but the exercises are of a different type. Okay. So, the whole theory of Milind says that if you do exercises, if you walk, that is not entirely sufficient. You have to do that kind of exercise which simulates injury possibilities. So, this kind of thing. So, you can see, right, middle-aged ladies and all kinds of old people over here, they are essentially doing boxing. Or here, this is Milind himself, he is trying to balance himself on a ball, which if you ever try to do this is actually surprisingly difficult. Okay, at your age you probably will be able to do it, you guys have a very flexible body. At our age it is very difficult, we tend to fall. Okay. And this kind of a stuff leads to an increase in the level of those chemicals which are associated with that risky lifestyle, and his claim is that this is what is going to prevent, or rather cure, diabetes much more effectively than drugs. So, there was one trial done of this kind in Oxford, but that was a very small sample trial. So, that is not entirely acceptable. So, right now they are doing this trial with a much larger number of individuals, and hopefully at some point we will be able to know whether this theory works or not. So, this is one example. There is one more example that is even more controversial, which is related to mental health. So, all of you know that nowadays mental health has become a huge problem, right, and lots of people are suffering from mental health. So, there is a evolutionary theory related to that which says that when we evolved in Africa, then we actually were very, very vulnerable. You guys know this, right, that human beings as animals are absolutely worthless. If you go to the jungle, then you can't run, you don't have sufficiently sharp teeth, you don't have any claws or anything. So, unless you make some tools, you will be dead within 24 to 36 hours, okay, depending on which jungle you have gone into. So, in the initial, and we have been like this for a long time. So, in the initial phase of evolution, if somebody went out of a group, that person was dead very soon. And therefore, the hypothesis is that evolution has made us very, very, how do I say, it has evolved mechanisms by which we cannot go away from a group. If we go away from a group, then we feel a lot of anxiety, a lot of tension, and all those anxieties and all those tensions actually manifest later on as depression. Now, what has that got to do with depression? So, what has happened is, one major change that has happened in our lives over the last 50-60 years or so is we have become very individualistic. So, if you remember, in India itself, about say 30-40 years back, we had joint families, right, and nowadays most families have become nuclear. More importantly, nowadays there is a very big focus on individual behavior, okay. That is why many of you spend hours and hours on social media, isn't it, Facebook and Twitter and other places, without really going out and playing with your friends. Now, this theory says that because humans are adapted to interacting with other humans, direct interaction, not through screen, therefore, when that direct human interaction goes away, human beings feel all kinds of chemical imbalance happens inside the mind, because of which human beings feel terrible, and that feeling terrible is what manifests as mental health issues. Again, this is something that people are still working on. This hypothesis is very strong. There are lots of predictions that have come out of this hypothesis, but people are trying to figure out where and how, whether this thing really works or not. But in the meanwhile, the first and the biggest thing that people say about mental health is, if you are suffering from mental health issues, please, please, please don't isolate yourself. Don't go on social media. Forget social media. Just go out with your friends. Okay, that is the biggest and the best thing that you can do. So anyway, so this is the main message. When situations change, so for example, when going from a group living to individual living, things that were beneficial earlier, they may not remain beneficial today. Okay. So the ability, the hyper efficiency of the human body to take energy and store, which was beneficial earlier, is no longer beneficial when you have lots of energy, and therefore, when that happens, things become harmful. So what you see is that when you think in terms of who is getting benefited, what is harmful, what is what was earlier beneficial and now harmful, etc., etc. When you think in terms of those parameters, suddenly you are not talking about biology anymore. You are talking about sports, you are talking about medicine, you are talking about mental health, all things which are very, very closely related to you. And that is why understanding about evolution is so, so important for everybody in the country, on this planet. If you don't understand about evolution, many of these things you will never think about. Incidentally, many doctors still don't think about these things like this. Okay, for them it is simply insulin going up, insulin going down, and that's it. And one of the fights that the evolutionary biologists are doing is to make them understand that bhaiya, this is how it works, and not necessarily the way you are thinking. I mean, that is correct at a mechanical level, that is correct, but the underlying ultimate cause is what we are talking about. Okay? And this is why many of us who study evolution, we are so upset that students like you may not know about evolution when they have taken it out of the syllabus, and this is why we want to organize events like this, just to show you how knowing about and how thinking about evolution is so critical for all of you. Thank you very much. Yeah, I'll take the questions after this. Tell me, somebody had something. Tell me.
Sir, yes. So, sir, basically what you mean is the core of all this is the game of mind, right?
Do I mean that?
Sir, when we like isolate ourselves from a group, okay, so some chemical reactions take place in our head. So these things do you think it's a game happening something in the mind that results in
No, but what do you mean by mind? Do you mean brain or do you mean something that is beyond the brain? See, problem is we don't even know what mind is. Okay. What we know is that the brain exists. What we know is that inside the brain there are lots of chemicals. What we know is that depending on the levels of those chemicals and how they interact with each other, our behavior, our mood changes. Okay. But what is the mind? The brain or the mood? Which one are you talking about?
brain?
Okay. So then you replace the question with brain.
Okay.
And then you say that is it all in our brain?
Is it all in our brain?
A lot of it is, because a lot of these chemicals are brain related, but the effect of those brain related chemicals are not only in the brain, they are all over the body. So you know that we have pituitary, we have many glands in the brain which are producing these hormones which are affecting our entire body. So just because something is happening in the brain doesn't mean that the effect is restricted to the brain, it goes all over the place.
Got it. Thank you.
So I wanted to ask about Wattway sir's theory. I had a doubt regarding that. So is he trying to say that simplifying our life is leading to diseases? Like he's saying that the absence of the running and the scars on our body and absence of struggle is leading to diabetes. So people are trying to simplify their lives. They are trying to utilize the technology in a way which would make the life simpler. So is he saying that doing that is leading to diseases like diabetes?
It is not about simplification, okay? Because in many ways our lives are way more complicated than our grandparents' lives. Think about it, okay?
Because resting in our home is simple than going out hunting. So that's what people...
True, but going to your school on a state bus is way more complicated than hunting. Think about it, okay? So it is not about simplification. It is about the loss of certain kinds of aggressions, okay? See, aggressions are of two types, okay? One is mental aggression. Suppose I am scolding you, I am being aggressive towards you, but that thing is not causing a physical problem. I mean, it is causing stress to you, but it is not causing physical damage to you. So that kind of aggression has increased greatly all over the place, okay? You shout at the whatever auto wala, you shout at the chai wala, all kinds of things end up happening. But that kind of aggression is not the point here. It is a specific kind of aggression which essentially leads, has a possibility of leading to wounds. Because the kind of chemicals that he is talking about, epidermal growth factors, etc., most of those are related to wound healing. And most of those actually have other functions in the body, all of which are then leading towards the diabetes. I mean, they are connected to diabetes. So it's not particularly about simplification, it's primarily about loss of aggression.
Like physical aggression.
Loss of physical aggression, yes, that is the thing.
Like if an individual decides to come out of his or her group, it also has its own advantages, right? Like if the group decides to dominate that one individual, if that individual comes out of the group, like he or she gets benefited.
Correct, but that is today. Okay, when you are in a school and you decide that okay, I will not play with these people, I will be alone, I will sit alone and read a book during lunchtime. That is okay, because that is not having any consequence for you, you are not dying. But we are talking about a situation when we were in the savannas of Africa. At that point, if an individual came out of the group, the individual was dead within 24 to 36 hours because of all the animals that were going around. Okay. So this evolution happened at that time, and those genes, they have stayed with us. And now when we are suddenly put in a situation where it is no longer problematic to go out from the group, and we are going out from the group all the time, that is when things are going wrong. Okay? That's the point. It's not about today, it's about what happened earlier.